Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A Level Chemistry Unit 2 for October 2021. This is the part 1 video, so let's begin with question 1. Question 1 is saying the infrared spectrum of an organic compound is shown below. So this is the infrared spectrum shown to us. And the first question is asking which of these compounds would give this infrared spectrum. They gave us hexanal. This is an aldehyde, so we expect to have a carbon-oxygen double bond for aldehydes as well as a carbon-hydrogen for aldehydes. So when you compare with the data booklet, you can observe that we are missing this peak here, and therefore it cannot be hexanal. I also saw hexanoic acid. We expect to have a carbon-oxygen double bond for carboxylic acids, a carbon-oxygen single bond for carboxylic acids, as well as oxygen-hydrogen for carboxylic acids. But this peak was missing, therefore that cannot be a carboxylic acid. And with the alcohol, hexane 1-ol, we expect a peak for oxygen-hydrogen for alcohols at that range, and that peak is missing as well. So observing the missing peaks here can help you detect whether it is the true compound or not. And therefore, I ruled A, C, and D out, leaving me with B as the suitable answer. That is why I marked B, hexane. Question 2 says, which of these compounds does not react with acidified potassium dichromate? 6. Acidified potassium dichromate 6 is an oxidizing agent. It means anything here that cannot be oxidized cannot be able to react with it. So this is a primary alcohol. Primary alcohols are oxidized by acidified potassium dichromate 6. This one is a secondary alcohol. This can be oxidized to ketones. That is an aldehyde. It can be oxidized to carboxylic acids. And this is a ketone. Ketones can never be oxidized, so the correct answer here should be the D here. Question 3 says, which of these compounds is a tertiary alcohol? As we can see, the first one is 2-methyl-propan-2-O. And now when I draw the structure, it looks like this. So it means this is a tertiary alcohol. You can already see it. The answer should be this one here. The rest are not tertiary alcohols. It's only this one here. So the answer should be that. So continuing down here in question 4, they say, in a mass spectrum, the molecular ion is the ion which always has the number 1, greatest abundance, that is wrong, greatest stability, that is wrong, highest charge is wrong, highest mass to charge, this is correct, because usually if you look at the mass spectra, the one that has the highest mass to charge is going to be the heaviest, and therefore is going to be the molecular ion peak towards the end of the spectrum that is provided to you. So the answer here should be a D. Moving on to question 5, butane 1-ol and butane 2-ol are isomers. Which mass to charge value would be expected to have a significant peak in the mass spectrum of butane 1-ol but not butane 2-ol? So here you would expect, remember we are looking for our significant peak. So butane 1-ol and not butane 2-ol. Let's look at the two structures. For butane 1-ol, fragmentation can be if we have a 15, maybe we have a 43 as well as a 57 if the OH has been broken off. But for butane 2-ol, we have a 15, we have a 29, and we have a 57. So we can see there is a 43 here. There is a 29, a 57, and so on. Even here, actually, we could have a 29. This one here, that can make a 29. So you can see, since the question is asking us for which mass to charge value would be expected to have a significant peak in the mass spectrum of butane 1-ol, but not butane 2-ol, we can see it's going to be this 43. That is going to be missing here, so the correct answer should be only that, only, because 43 is only present in butane 1-ol. The answer should be C. Question 6 says, which of these isomers has the highest boiling temperature? Since all these are isomers, the one that has the least branching should have the highest boiling temperature, and this one has the greatest branching. So this boiling temperature is going to be very low. This and that is going to be lower in comparison to this. So the answer here should be A. The reason for this is if there is no branching or less branching, it means there are more London forces that can be formed, and therefore you will require a higher temperature in order to separate the molecules. That is why A is the suitable answer. It has the least branching, or in this case, it has no branching at all. Let us continue to question 7. Question 7 says, organic reactions can be classified in different ways. How should the reaction shown be classified? We can see here an alkene being converted into an alkane. So this should be an addition reaction because something has been added and the double bond has disappeared. This is not oxidation, it's not polymerization, not substitution. it is addition reaction because an unsaturated compound has been turned into a saturated compound. So part B here says, how should the reaction shown be classified? This reaction here is of course oxidation. We can see the alcohol is converted into a ketone, so that is an oxidation reaction. The answer should be a B here. Question 8 says data for some group 1 and group 2 cation are shown in the table. So these cations, they give us their radius as well as the charge. And they say which cation would be expected to form the nitrate with the greatest thermostability. For the nitrate to have the greatest thermostability, it means it requires more energy for it to be decomposed. And that means the cation in that nitrate should have the least polarizing power, meaning the cation should have the biggest size or the biggest ionic radius, and it should have a lower charge. So when we look at the table, it's only cation Z that suits that. It has the greatest radius among them, and it has a lower charge, so the answer should be the D. I put extra explanation here. You can refer to that as you try to revise. For question 9, they say, the equation for the complete conversion of propan-1-O is shown, as you can see there. And they said 2.00 times 10 power negative 3 mole of propan-1-O undergoes complete combustion. And they say what mass of carbon dioxide is formed. If it undergoes complete combustion, it means all this is going to be converted into those products, and it means 2 moles will all be used up. Using the equation's mole ratio, which is 1 to 3, I can be able to find the number of moles of CO2 produced. So moles of produced carbon dioxide are 3 times the moles of the initial alcohol, which gives us that. And then the mass of the produced carbon dioxide should be number of moles times the molar mass, which is going to be 6 times 10 power negative 3 times 44, and we get 0.264 gram. And the answer should be a D here. Question 10. This question is about the reaction shown. This is the reaction they've given us. And they say what value of X, Y, and Z are needed to balance the equation. I began by looking at carbon on this side, because carbon on this side is only found in carbon dioxide, and on this side is only found in this compound here, so it's easier to balance that. Since I have 10 carbons here, I had to create 10 carbons on this side, and multiplying the 2 by 5 creates 10, so X should equal to 5. Then next, I went for the sulfates. We can see from this side, sulfates are only here and here, making a total of 3. 1 plus 2, that is 3. And since sulfate is only found in one compound on this side, it's easy by making Y is equal to 3, that creates 3 sulfate this side. So my Y is 3. And finally, I went for the hydrogen. So to be able to find the value of Z, I know that here we have 5, so we have 10 hydrogens here, and we have 3 times 2, so 6 hydrogens, a total of 16 hydrogens on this side. I have to create 16 hydrogens on that side as well. To do so, I have to make Z equal to 8. So I have X is 5, Y is 3, and Z is 8, and the possible answer is going to be a C here. Next, they say, what is the reducing agent in this reaction? A reducing agent gets oxidized. Now, if we consider, can you look at the carbon here? It's +3 oxidation state, and it's converted to +4 oxidation state. So we can say that this in that is going to be the reducing agent because it gets oxidized. So the answer here should be a B, as we can see. Question 11 says, what is the oxidation number of phosphorus in the phosphate ion? So since this is the ion we're talking about, making the oxidation state of phosphorus to be X, oxygen here is -2, so -2 times 4 gives us -8, and equate the total to -3, which is the charge on the whole ion. When we make X the subject, we get X is equal to +5, so phosphorus is +5 oxidation state in that. So the answer here should be a C. Question 12 says, which reaction is not a redox reaction? A redox reaction meaning there is no oxidation as well as reduction occurring at the same time. Here we can see this is going to be a redox reaction because they are different chlorine species, or chlorine species I would call them. And then in here we can see this is chlorine is -1, still -1 on this side, hydrogen +1 on this side, barium +2. There is no redox reaction here. So the answer here should be a B, but I can try to go further. This is a solid becoming an ion, that is oxidation, and this is an ion becoming a solid, that is reduction. So this is a redox reaction. For this one here, we can see, of course, there is a redox reaction from your textbook in topic 8. This is one of the redox reactions stated there. Chlorine gas reacting with water being converted into C. This is a -1 oxidation state as well as that. So this is a redox reaction as well. So the answer here should be easily a B. Continuing on, question 13 says a student is provided with 25 centimeters cubed of 1 mole per decimeter cubed hydrochloric acid. They ask what volume of distilled water should the student add for the solution to make it to 0.05 mole per decimeter cubed. So the original, this is what we have, 25 centimeters cubed. We have the concentration 1 mole per decimeter cubed. The number of moles in here should be concentration times volume, which is 1 times 25. We divide by 1,000 to convert that volume to decimeters cubed. And here we get the number of moles present in that as 0.025. The desired sample is going to have a concentration of that. So if the concentration is 0.05 and the number of moles that are going to be present as 0.025, what volume are we supposed to use? So volume should be number of moles of a concentration, which is that divided by the concentration. And when I calculated, I got 0.5 decimeters cubed, which turns out to be 500 centimeters cubed. So the total is the difference between the two. So here we see this is 500 centimeters cubed. Remember, we are going to add water. So we need 500 centimeters cubed minus the 25. The water to be added should be 475 centimeters cubed, and the answer should be a C. So question 14 says, which statement about group 7 element chlorine, bromine, and iodine is not correct? They say their boiling temperature increases down the group. That is correct. Reactivity increases down the group. That is wrong. Group 7 elements react by receiving electrons. So if they react by gaining electrons, it means the one that has the smallest radius should be the most reactive. And since the radius increases as you go down the group, the reactivity should be decreasing. So that is wrong. Question 15 says, when iodine is dissolved in a nonpolar organic solvent, the solution formed is, of course, it's going to be purple. The answer should be an A. Moving down here, they say, which row shows the hydrogen halides in order of increasing boiling temperature? This is also in your textbook, this type of graph. If we have hydrogen halides, because hydrogen fluoride has intermolecular hydrogen bonds, we will see that it's going to have an abnormally higher boiling temperature in comparison to the other halides. However, these ones here have only London forces as well as permanent dipoles, so we expect their boiling temperature to gradually increase as the molecular mass or the number of electrons present increases. So this is going to be high, then we see a drop, and then a slight increase as we see there. So it should be, the lowest should be hydrogen chloride, then we go to hydrogen bromide, hydrogen iodide, and then hydrogen fluoride to be the highest among them all. So the answer here should be a C. And let's continue to question 17. It says, solid potassium bromide reacts with concentrated sulfuric acid. They say which of these substances does not form. Potassium bromide contains a bromide, and reaction with sulfuric acid is going to produce 3 products. One is going to be HBr, the other is going to be sulfur dioxide, and the other is going to be bromine. So the one that is not going to form is hydrogen sulfide. So the answer should be a C. Again, this is present in topic 8 of your textbook. Lastly, here they say 10 grams of hydrated magnesium sulfate that is heated to remove the water of crystallization. They ask what mass of anhydrous magnesium sulfate is formed. Remember, this is anhydrous magnesium sulfate, so it means the reaction that is going to take place is this. All the water of crystallization is going to be removed. And since they told us this is going to be 10 grams initially, I found the number of moles by getting the mass divided by the molar mass, which we were given here, and I got these moles. However, when you look at the reaction equation, the mole ratio is 1:1, and that means the moles of these are exactly the moles of that, which are these. Then when I use the number of moles to find the mass of magnesium sulfate, so the mass here should be number of moles times the molar mass, which is those moles times the molar mass of magnesium sulfate, and I got 4.886, which is approximately 4.89, and the possible answer should be a B, as we can see here. So this brings us to the end of question 18, as well as the end to this video. Thank you for being with us. Please do not forget to subscribe. See you in the next video. Bye-bye.